All right. So these first two are from our previous test. We want to have theta be an acute angle. We want to draw a right triangle and find the trig function they ask us for. So if it says draw a right triangle, then draw a right triangle. It can be any kind of right triangle you want. It just needs to be one that has a right angle. And you want to label one of your other two angles, and it doesn't matter which one. So I like to label the bottom left one, but if you wanted to label a different one, that's fine. If that's where theta is, and tangent, which is opposite over adjacent, is 4 over 5, that means my opposite side is 4, my adjacent side is 5. That's what my triangle is going to look like. Then what we want to do is find the hypotenuse, because secant is hypotenuse over adjacent. So we want to use the Pythagorean theorem to find the hypotenuse. So I'm going to do 4 squared plus 5 squared, because those are both legs on my triangle, legs of my triangle, and then that's going to be c squared. So I have to work out what is 4 squared plus 5 squared, which is 41, and then square root both sides so that my hypotenuse is the square root of 41. I'm not going to worry about typing that into my calculator. I'm just going to leave it as the square root of 41. That's the hypotenuse. So secant is hypotenuse over adjacent, so that's square root of 41 over 5, and that's my answer. And then the next problem is really similar. They just give us cosine and we're going to find sine. So set up your right triangle if you haven't already. All of your right triangles can look pretty much the same if you want them to. Pick an angle. Think about what cosine is. It's adjacent over hypotenuse. So that means 6 is the side next to theta and 7 is the hypotenuse. So this time when I set up the Pythagorean theorem, I don't know both legs, so I'm going to have to solve for whatever this is, which makes the problem a little different. Instead of adding 6 squared and 7 squared together, I need to subtract them, because I'm going to have to move this over to this side to get a by itself. So 7 squared minus 6 squared gives us 13, and then we square root both sides, and we get square root of 13. Again, you don't need to type that in your calculator and get a decimal. We leave it as square root of 13. We put it on this side, and then we say, what is it asking for? It wants sine, so I'm going to do opposite over hypotenuse, which is square root of 13 over 7. And that would be my answer. Questions on those two? All right, the next one, this is also from the previous test. Find a positive and negative coterminal angle. That's where we had to add and subtract 2 pi. But the problem with adding and subtracting 2 pi when I have a fraction is I need to get a common denominator. So that fraction has a 3 on the bottom. I want to make this fraction have a 3 on the bottom. So I times the top and the bottom by 3. So what I'm really doing is 5 pi over 3 plus 6 pi over 3, and then 5 pi over 3 minus 6 pi over 3. So that's 11 pi over 3 and negative pi over 3. The only problem with you just converting it and doing it that way, so converting 5 pi over 3 and then adding and subtracting 360, is then you still have to go and convert it back, because the answer needs to be in radians if they gave us the problem in radians. So if you want to go through all that effort, be my guest. The important thing is what they start off telling us. They start off telling us 12 inches in diameter and 55 revolutions per minute. The other thing I want to look at is what they asked me for. They asked me for radians per second, and then they asked me for feet per second. So I'm converting, and I have to say, what rate did they start off telling me? They started off telling me 55 revolutions per minute. So I'm going to put 55 revolutions over 1 minute, and I'm going to do this thing that in chemistry we call dimensional analysis, but in math we just call converting. 55 revolutions per minute. If I want radians per second, well, the minutes part of that is easy. How many seconds are in a minute? 60. I want the minutes to cancel, so minutes needs to go on top and seconds needs to go on bottom because I want to get rid of minutes. Then I need to go from revolutions to radians. And so if you haven't already written it down on your perfectly allowed sheet of paper, 1 revolution is 2 pi radians. And so that means that I need to put 1 revolutions on bottom and 2 pi radians on top. So my revolutions will cancel out. That means I have radians per second, which is what we are asked for. So I multiply together on top and I multiply together on bottom. And then I simplify. 110 over 60 is 11 over 6. So 11 pi over 6 radians per second. I don't have a problem with you finding a decimal for that if you really want to, because typically on word problems, decimals are okay because it's more of a real world situation where you would end up rounding eventually. That's the first part. Now we want to take that and convert to feet per second. So I'm going to take the 11 pi radians over 6 seconds, and I'm going to say, how do I get this instead to be feet per second? Well, the second part of that is fine. How do I go from radians to something like inches or feet? 1 radian equals my radius. Okay, so to get rid of the radians, I need what the radius is. If my diameter is 12 inches, my radius is 6 inches. Yeah. Yeah.
How do you find linear speed?
We're going to multiply by the radius, and then we're going to have to convert a little more. So here's the radius, but right now that's inches per second, and they asked me for feet per second, so I need to go from inches to feet. There, yeah.
You have to multiply the English speed by whatever the radius is and you convert to the... Okay.
Yes. So I put 12 inches on bottom and 1 foot on top, and then that gives me 66 pi feet over 72 seconds, which simplifies to be 11 pi over 12 feet per second. Number 5, find the exact value of the trig function. Use the unit circle. So do I want to use my calculator on this problem? No, I'm going to use the unit circle. Tangent, somewhere on your unit circle, it should say, hey, tangent is y over x. 4 pi over 3, if you look for it on your unit circle, is down here. And that point is negative 1/2. And negative square root of 3 over 2. So if I put my y value over my x value, then that's negative square root of 3 over 2 over negative 1/2. And from here, this is simply an issue of how do I divide fractions? I take the first fraction and leave it alone, and then I multiply by the reciprocal of the bottom fraction. So I flip the negative 1/2, which means the 2's cancel. The negatives cancel because 2 negatives in math and English make a positive, and I get square root of 3. 2 negatives in English is a double negative and makes it your sentence positive. All right, number 6 says to draw a right triangle. We're using this point. So draw an x and a y axis, and then where I put that point has to do with where is negative 5, 2. Negative 5 means I need to go left. Positive 2 means I need to go up. So my triangle is going to be over here. This side is negative 5. This side is 2. If I want to find all 6 trig functions, okay. So we're going to draw this point, negative 5, 2. So we have to go left 5 and up 2. And we can draw a triangle because of that. And so we want to find sine, cosine, tangent, and then cosecant, secant, cotangent. And if you look on our unit circle, we wrote down what each of these are. You can either use like opposite over hypotenuse, or you can use where we said that sine was y over r. R is the hypotenuse. So we're going to have to figure out what the hypotenuse of this is using the Pythagorean theorem. And when we use the Pythagorean theorem, either just ignore the negative and don't put it in at all, or make sure it's in parentheses. So this is 4 plus 25, which is 29. And then we square root both sides, so the hypotenuse is square root of 29, or that's the same thing as r in our formulas. Sine is y over r, so that's going to be 2 over square root of 29. Which goes to 2 square roots of 29 over 29, because I have to rationalize. So I multiply the top and the bottom by the square root of 29. And then cosine is negative 5 over square root of 29. And then I rationalize that and make it negative 5 square roots of 29 over 29. Tangent is y over x, so that's 2 over negative 5, which I don't have to rationalize. And then the last three are the reciprocals of the first three. So I'm going to look here before I rationalize, and I'm going to flip this. So this is square root of 29 over 2. Secant is square root of 29 over negative 5. And cotangent is negative 5 over 2. If you flip it after you rationalize, you're going to have to rationalize again, which is super annoying. And you still should end up simplifying and get what we got. So flip before you rationalize when you're finding cosecant and secant on that problem. That is everything that's related to the stuff from the first test. So everything else is from 4.5 through 4.7. So on 7, the amplitude is the number in front of our trig function. The period is 2 pi over what's in front of x. Now, what is in front of x on here is not just 4, it's actually 4/5. Okay, so if they give you a fraction, that whole fraction has to go on the bottom. So what I do is I say, well, that's 2 pi over 1 times the reciprocal of the bottom. So I multiply by the reciprocal. So 2 pi over 1 times 5/4. If you multiply that out and get 10 pi over 4, then that simplifies to be 5 pi over 2. Or if you simplified before you multiplied, that's fine too. Either way, we should get 5 pi over 2 for the period.
Does the negative in front of 3.5?
It is not a part of the amplitude. The amplitude is positive 3.5. And so you might make a note to yourself that amplitude is never negative. We take the absolute value of whatever's in front of sine or cosine so that it's never negative. Number 8. So this is from 4.7. The first one of these three problems is the most tricky. We want, where is our y over our x value going to give us positive square root of 3 over 3? Arctangent is only in the first and the fourth quadrants, no matter what, okay? And that's something that we have written down in our notes. That's something you can write down on your perfectly allowed sheet of paper. If it's positive, that means we're looking in the first quadrant, so I don't even need to worry about down here. So I'm basically looking at these 3 points on my unit circle and saying, which one of those, if I put my y value over my x value, will I get square root of 3 over 3? Worst case scenario is you sit and work out every single one of those and see which one it is. Best case scenario is you use logic and reasoning to figure out that it has to be the first one down here, square root of 3 over 2, which that does not look like a 3. Square root of 3 over 2, comma 1/2. What?
What quadrants are they usually in for arctan?
Arctan is first and fourth. if I put 1/2 over the square root of 3 over 2, my 2's will cancel because they're both on bottom, and then I'll have 1 over the square root of 3, which we have to rationalize, and that's how we get square root of 3 over 3. So what I need is the angle that goes with that first point. They tell me to answer in radians, so my answer is pi over 6. That's not a 6. Let me try that again. Pi over 6. That's as difficult as that problem can get, because that's as hard as, like, that's the opposite basically of what we had to do on like number 5, where we had to simplify it once we knew where our angle was. So these other two are actually easier. Arc cosine asks us, where is our x value 0? Arc cosine has to be in the first or second quadrant. And so we look at our unit circle at the top here and we say, where is the x value 0? Which happens up here at 0, 1. So that angle in radians is pi over 2. And then 10, where is our y value, square root of 2 over 2? Arc sine is in the first and fourth quadrant. So since it's positive square root of 2 over 2, then I'm going to look up here. That point is at pi over 4. So I showed work on all of these because I'm trying to explain to you how you get it. There's really not much work except maybe on the first one of those, if you're having to actually figure out which one simplifies to be that, that might take some work. But otherwise, you're just looking at your unit circle and figuring out what angle is the right angle. All right, 11 and 12 are very similar. On 11, we are given arc cosine of 5x, and we're going to use that to come up with a triangle. Now to do that, I need to put this over 1, because cosine is adjacent over hypotenuse, and so without that over 1, then I don't know what my hypotenuse is supposed to be. We need to draw a triangle, and then label our angle so we know what our perspective for this is, because the adjacent side of this would be the bottom. The hypotenuse would be 1. And if it throws you off that our hypotenuse is 1 and our adjacent side is 5x, and it seems like 5x is bigger than 1 and that's not supposed to happen, we would have to pick x's that are really small to make this work. So that this side would end up being like a fraction, so that it's smaller than 1. But that's not really super important here. We need to find the third side of this. So I'm going to use the Pythagorean theorem. So I need to say 5x squared plus my missing side squared equals my hypotenuse squared. Notice I put 5x in parentheses, because if I square 5x, I have to square that whole thing and get 25x squared. Then it's important to remember we're not solving for x, we're solving for a. So I need to subtract 25x squared. And then square root both sides. And then remember that 99.9% of the time, this will not simplify, so don't even try. And it's because of the minus sign. If we were multiplying underneath our square root, yes, we could simplify this, but we're not. We're subtracting, and subtraction ruins everything. You might remember that from like first grade. Addition was great, and then they introduced subtraction, and it went downhill from there. I'm just kidding. I don't really feel like that. Subtraction's awesome. Tangent is what I'm looking for, so I'm going to put the opposite side over the adjacent side and box that answer, because I can't simplify that either. So 12 works out really similarly. We're going to set up a right triangle. Tangent is opposite over adjacent, so x and 8 are my opposite and my adjacent sides. Pythagorean theorem to find our third side. So x squared plus 8 squared equals c squared. This time I don't have to subtract anything, so I can square root both sides and change the 8 squared to a 64. And that's my missing side up here. X squared plus 64 under a square root. Sine is opposite over hypotenuse, so that's x over the square root of x squared plus 64. But I have a square root on the bottom, and I want to rationalize that, so I'm going to multiply by the square root of x squared plus 64 on the top and the bottom, which gives me x square roots of x squared plus 64 over x squared plus 64. There will be a problem like 11 or 12 on the test, and I would say of the new stuff we did, I feel like that's probably the thing that you guys think is the hardest. If you don't think it's that hard, that's good. If you do, that would be one to look at extra right before the test so that you remember how to do it. All right, 13 and 14, I forgot about these. These are also technically from the last test, so the problem on this is knowing which quadrant to draw your triangle in. And so tangent is positive 3/4, and sine being greater than 0 means that sine is positive. So in which quadrant are tangent and sine both positive? The first one. That's the only place where if you're given two trig functions and they're both positive, it has to be in the first quadrant. So I draw my triangle and label my sides, and I figure out what the third side, this is a 3, 4, 5 triangle, or I can use the Pythagorean theorem to figure that out. And then I say, well, cosine is adjacent over hypotenuse, or x over r, or whatever you want to, whichever way you want to think of that. So my answer is 4/5. (14) is trickier because tangent is negative and sine is negative, because sine is less than 0. So here I have to say, where is tangent negative? That happens in the second and the fourth quadrant, because all of them are positive in the first quadrant. And then if you have it written down on your perfectly allowed sheet of paper, all smarties take calculus. Tangent is positive in the third quadrant. So it can't be first or third. Sine is negative in the bottom two quadrants, so it can't be the second quadrant. And so that means my triangle has to be down here in the fourth quadrant. So my opposite side is -4 and my adjacent side is 9. That negative could have gone with either of those. I know that the 4 is negative because I had to go down 4 and I went right 9. And so the down part of that is negative, the right part is positive. Now if I want cosine, I need to find the third side. 9 squared plus -4 squared equals c squared. 9 squared is 81, -4 squared is 16, giving us 97. Okay. Okay, 15. I told you guys, let's pretend that they told us they wanted sine for this, because we'd have to know which trig function they were talking about to be able to write this. We want to write y equals, and we just need to figure out, what do I do with the amplitude and the period? So the amplitude is what's in front, so this is 5.5 sine. The issue with this is the period doesn't tell us what goes in front of x directly. Like, I'm not going to put 3 pi over 4x. I have to work out what's supposed to go there, because 2 pi over b is 3 pi over 4. Okay? The way we find the period is by doing 2 pi over b. We don't know what b is, so we need to find b. Now, most of the other ones we've done, it was a lot easier to just look at it and guess, but this isn't particularly easy to look at and guess. So we would cross multiply.
So why is it 2 pi over b again?
Because the period for sine is 2 pi over b.
Okay.
So we're going to cross multiply. So 2 pi times 4 is 8 pi. 3 pi times b is 3 pi b. And I'm trying to solve for b, which means I need to divide both sides by 3 pi. That means my pi's cancel, and b is 8/3. B is the number that goes here in front of x, so this is 8/3 x. And that would be my trig function. A calculator might be helpful for 16 through 22, by the way. On 16, it says state the period and amplitude, make a table of values, and graph the trig function. Label the x and y axes, please. So the amplitude of this is the number in front of sine, which is 4. We don't put a negative there because that's not a part of the amplitude. Amplitude is the distance it goes up and down, and distance can't be negative. The period is 2 pi over what's in front of x, and since that's just a 1, the period of this should be 2 pi. So if I want to fill in this table of values, I can get on my calculator in radian mode, and I can type in -4 sine of 0, and then press enter, and -4 sine pi over 2, and press enter, and so on, and I can get these answers. So like when I plug in 0, I should get 0.
So you plug it in as -4 instead of 4?
Yeah, when I'm plugging it into the calculator, I use this equation.
Okay.
So I'm only ignoring the negative when I write down the amplitude, not whenever I put it in my calculator.
Okay.
So this is 0, and then -4, 0, +4, and 0. Now when we go to do this, because we're going to plot these points, I need to label pi over 2, pi, 3 pi over 2, and 2 pi. And that's what it means by label your axes, is that I can't just like draw a picture and not say what these things are. On the y-axis, I need to go up and down to 4 and -4. So 1, 2, 3, 4. 1, 2, 3, 4. And then I'm going to plot these points. So 0, 0. Pi over 2, -4. Pi 0. 3 pi over 2, 4. 2 pi 0. And then connect this in a curvy fashion. Remember, these are not supposed to look super triangular. Or like V's. They shouldn't look like V's. They should look kind of like N's. Do your best though, because it can be hard sometimes. So on this section up at the top, we have a whole bunch of equations. There are 12 of them. We have 6 graphs and 12 equations, which means you can't just use the process of elimination entirely. You're actually it's better than you having to come up with it by yourself, but it's not like you can just do 5 of them and then guess on the last one. So for 17, what I want to do is I want to look at this and say which set of trig functions in it. It's not tangent, cotangent, secant, or cosecant. It has to be sine or cosine. And from there I look at it and try to find what tells the difference between sine and cosine. Sine starts at 0, 0. Cosine starts at the top amplitude or the bottom amplitude. So this has to be sine. So I go and I look at the top of my paper and I say, well, what are my options here? My options are 2 sine 4x and 2 sine 2x. So I have to either come up with a way to look at this graph and tell which one of those it is, or I need to get on my calculator and graph both of those and see which one looks right. If you graph both of them to see which one looks right, you would want to change your window to what the window of this graph is, which is 0 to 2 pi and -6 to 6, so that it actually looks right. Whichever way you decide to do it, we should get 2 sine 4x. So either by plugging both of those in and saying which one of these looks more like it, and to do that you're basically saying, like, counting how many times it goes up and down by the time it gets to 2 pi. So it goes up and down 1, 2, 3, 4. Oh, and that's the number that's in front of x is 4. However many sine curves it does, or cosine curves it does by 2 pi, that's the number in front of x. What? Okay. The period of this is 2 pi over 4, which is pi over 2. The amplitude is 2. So on 18, it's not sine because it starts up here at 1/2. Oh, hey, I just figured out the amplitude is 1/2. My choices for cosine are really similar to what they were for sine. 1/2 cosine 2x or 1/2 cosine 4x. So I either need to graph this on my calculator and compare them to decide, or we can actually do the same thing we just did. Here is a cosine curve, here's another cosine curve, here's another cosine curve, here's another cosine curve. So there are 4 of them, which means it's 1/2 cosine 4x.
Will that work every time?
Every single time. But you have to make sure you're paying attention to the fact that it's by 2 pi. How many times did it happen? So the period of this, just like it was on 17, is 2 pi over 4, which simplifies to be pi over 2. What?
You said M2 is 1/2? Okay.
Because it only goes up to 1/2 and down to 1/2. And it's the number in front of sine or cosine. Okay, so these next two are either secant or cosecant, and so you have to look and decide which of these is secant, which of these is cosecant. And on our sheet that we made the other day, we said, hopefully we said something like, cosecant is the one that has an asymptote at 0. So I know this has to be cosecant. Secant is the one that goes through the y-axis. So this one is secant. From there, I look at my options. So on cosecant, I either am doing cosecant of x plus 2, or I'm doing 2 cosecant x. Let's remind ourselves how to put this in the calculator. Cosecant goes with sine. So this first one, if I wanted to type it in, I would do 1 divided by sine of x plus 2. The second one would be 2 divided by sine. Okay, so it matters that you can put it into the calculator correctly. Cosecant is 1 divided by sine. So what's happening here is that this is being stretched by 2 because this distance from 0 is 2. So it should be the second one, which is y equals 2 cosecant x. That's if I wanted to do it without my calculator. With my calculator, I just graph both of them and see which one looks right. So the period of this is 2 pi over what's in front of x, which is 1, so it's just 2 pi. My choices for secant are 3 secant x and 3 secant 2x. The difference between these is how many times am I going to have a secant happen by 2 pi? Because this one, just like what we said a second ago, this is saying that I should have 2 secants by 2 pi. Well, a secant is this, this, and this other half. That's happening by 2 pi. So it's not going to be the one with a 2x, it's just going to be 3 secant x. And so that's why we highlighted on our paper and said, well, what's a period of secant? It should be the first or the second half of this u, the n, and the first half of this u is one secant curve, and that's happening by 2 pi.
Is there going to be an answer bank on the test like that?
Yes, and it'll be very similar where you're probably going to be able to narrow it down to 2 things really easily, and then you'll have to decide which of those 2 things it is.
Oh, and on cosecant, the period is the same for secant.
Yeah,
To figure it out like the
2 pi over what's in, yeah, yes,
No,
yes,
I'm
you,
talking about for the little highlighted square, whatever that
yes.
little thing.
Mm-hmm. All right, we know these are tangent and cotangent. Tangent goes up to the right and down to the left. So this has to be tangent. This has to be cotangent. So tangent, our choices are 4 tangent x minus 1 and 3 tangent 2x minus 1. So both of these are saying we're shifting down 1. Both of these have a vertical stretch, and this also has a horizontal shrink. So the fastest way to come up with this is to look at our asymptotes here that are at pi over 2 and 3 pi over 2 and say, is that where the asymptotes normally are for tangent? And because that's where they normally are, that means I did not horizontally shrink this. And so it has to be the first one where there's not a horizontal shrink. If I had a 2 in front of x, these asymptotes would be moved in closer to the x-axis, to the y-axis, because there would be a horizontal shrink. So it has to be 4 tan x minus 1.
Where did the 4 come from again?
From the answer bank. It's because there's a vertical stretch of 4. Like normally by this next line, normally we only go up 1, but we've gone all the way up 4. So we've gone up 4 instead of just going up 1, so we vertically stretched it by 4. The period for tangent is normally pi over b, and b is 1, so it's pi. Our choices for cotangent. I thought the cotangent one was the toughest one of these personally. I don't know if I'm alone in that, but basically the difference between these two are very, very small. One of them is being vertically shrunk by a half and the other one is not. So honestly, you'd probably be best served to put this in your calculator. What I would do is I would say something like 1/2 times 1 divided by tangent, because cotangent and tangent go together, and then plus 1. Or this would just be 1 divided by tangent, x plus 1. And then there's a trick you can do on your calculator where you press trace and then you can type in a number. So if I press trace and type in a number like pi over 4, and press enter, it will tell me what that's supposed to be. What I want it to be is 1.5 for this graph. The one of these that happens with is on the 1/2 cotangent x plus 1. Not on cotangent x plus 1. This one is really hard to know the difference on. We are moving this graph up 1, and then it's only going up a half either direction, up and down a half by the next point. So it has to be a half cotangent. And the period of this is pi over b, so it's just pi. These last 3 questions have to do with your understanding, or at least on 23. Which of our trig functions has asymptotes at pi over 2, negative pi over 2, and the period of it is pi? So look at your trig functions and look through and see which one of those has those properties. Pi over 2, negative pi over 2, and a period of pi is which trig function? Not cotangent, tangent. Because tangent, you have an asymptote here, and then it goes through 0. So the period of this is pi, and it has asymptotes at negative pi over 2 and pi over 2. 24, the 2 affects the graph by making it a vertical stretch of 2. So we're remembering our transformation rules here. It's a vertical stretch of 2. The negative 7 at the end is a shift down of 7. Never before have I written an of there. Okay, shift down 7. Will the asymptotes move from positive and negative pi over 2? Why or why not? How can I figure out where the asymptotes for this are? Well, I can graph it on my calculator, and that would be one way of doing it. They will not move from positive and negative pi over 2, though, and the reason is because there's nothing inside my parentheses with x. That's what causes our asymptotes to move, is having something inside with x. So I would say no, because there is nothing inside the parentheses with x. And so 25 is kind of the opposite of that. What two characteristics of the graph will the 2 affect? The 2 is inside of the parentheses, so it's going to affect the period and the asymptotes. We just said that what's inside with x affects the asymptotes. Well, there's something inside with x. It's going to affect the two things that are horizontal, which is the period and the asymptotes.